system. Even though I've already shared with you on the recorded versions, but today we're gonna discuss further on this lecture 4. Let me share with you the slide. Okay, can you see this slide, class?
Yes. Answer.
Okay. Okay, we're going to discuss today on this normal tangent coordinate systems. As what is explained before, that the normal tangent coordinate system is one of the method of solutions, or a method, a way of solving the problems in curvilinear motion, especially for object, physical body, or particle which move according to curvilinear path of motions or circular path of motions. Yes. As you can see here, we have this flying jet, which in this simulations it's moved according to circular path of motions. And if we have this kind of problems, and they ask you to find out what, let's say they ask you to find out what is the displacement, what is the uh, velocity of this particle or this jet fighter, which move according to this circular path of motions, and these instant shows, they ask you to find out what is the normal component of accelerations or tangent component of accelerations. Then we can apply method which is called as normal tangent coordinate system. So let's continue with this next slide. Describe the part of using normal tangent coordinate which adds normal and tangent to the parts. Consider particle move on plane. We have this kind of illustrations. We consider that P represent on a particle which move according to this path of motions, and this instance shows it has an origin of O at a fixed point on the curve, as you can see here. So we have this UT, and also UN. UT and also UN actually represent on the unit vector of these tangents axis, or T axis. To axis tangent to the curve at P. So if you look at these illustrations, so this at P. So this UT is actually represent on unit vector. So T axis, this T axis, this one, is tangent to the curve. So we have this curve. It's always tangent to the curve. At P, we have this particle P. And is positive in the direction of increasing S. So it's moved to this direction of motion. So it is positive in this direction. So that is T exists, which is designate this positive position direction with the unit vector of UT as what is as mentioned before. Segment ds actually represent on the displacement which occur on this particle P. It's formed from the arc having a radius of curvature rho. So rho is the radius of curvature. Which is symbolized as rho or designated as rho. And O primes, this O prime is actually center of curvature. So any particle which move according to curve within the path of motions or circular path of motions, it will has the also called the radius of curvature which need to be considered, and also we need to consider also the, of course, when it has the radius of curvature, it will also has the center of curvature. Let's see, we have this particle which move according to the circular path. So of course adalah dia punya jari pula. Radius R. R is the radius. Betul lah jari dalam bahasa Melayu.
Yeah.
Okay, jari kan. Jari R is the radius. So it's half of the diameter of this circular part. So R is equal to rho lah. Okay. So we need to consider all this kind of thing when we deal with this normal tangent coordinate system. And the next is a normal axis N. N is perpendicular to the T axis. So we have, let's say we consider on this, to illustrate this. We have this particle P, and we consider that we have this T represent on the tangent axis. Normal axis is always perpendicular with T axis, 90 degree. So this one is N. N is normal. So T adalah tangent. It's directed from P. Let's say we have this P directed from P toward the center of curvature. So let's say it has the center of curvature in approximately at this point. We can put it as O or O prime or whatever it is. Designated by the unit vector of UN. So N, the unit vector adalah UN. Plane containing both normal and tangent axis is known as the osculating plane, which is fixed on the plane of motion, osculating plane. So if you have this kind of path of motions of this particle, kat sini ada tangent, ni ada normal. In whatever direction of motion for this this N. Kalau dekat sini kedudukan dia, let's say this P, ini adalah P prime. So dekat sini pun dia ada tangent, the other normal. This one is also osculating plane, normal and tangent, which is fixed on the plane of motions. It is always fixed in the plane of motion. Kalau dekat sini, it's become like this lah. So this one is T, tangent dia adalah kat dalam. Normal dia adalah toward this curve, toward this inside in this curve. Ini time. Okay, we have this anti-coordinate systems. Okay, we have, let's say, we have these situations of particle P, which move according to, in this case, it's move according to circular path of motions. You can see, watch this slide on this circular path of motion of this particle P. Which move to these directions, counterclockwise rotations, P, and then it's a P naught, and then it's P1, and delta S is the displacement. Delta S is the displacement, and when it's moved according to curve or circular path of motions, we need to consider on angular motion. So when we talk about these angular motions, it's related with this theta, angular positions. It's related with this d theta is the angular displacement. It's related with this omega, or this one is equal to theta dot. This one we call it as angular velocity, and we need to consider also the with this alpha ataupun omega dot, ataupun this one is equivalent to theta double dot is the angular acceleration. So since we consider all these curve-related motions, so it's related with this, of course, with the circular path of motions. If we consider these situations, we need to take into account on the angular motions, theta, d theta, omega, and also alpha. Okay, the next concern about distance and velocity in normal tangent coordinate system. As you can see, we consider only the same illustrations of particle P, which move according to circular path of motions. So the distance travel is symbolized as delta S. Delta S is equal to R d theta. Okay, let's say we consider the first equations. So basic equation for this actually is S is equal to R theta. Yeah. Delta S is equal to R d theta, or we can write it down as a ds is equal to R d theta. And when we talk about these angular motions, in this case, let's say we have this angular velocity, which is symbolized as that omega. So omega is equal to delta theta over delta t. Omega is the angular velocity. It's change of particle displacement which move according to the circular path of motions at an interval of time t, also delta t, delta theta over delta t, which can be written as is equal to d theta over dt. So d theta over dt is equal to theta dot is equal to theta dot adalah sama juga dengan this omega. And we know that V is equal to delta S over delta T is equal to, you know that is delta S from 1 from equation 1, which is this one. Substitute into this V is equal to delta S over delta T. Delta S is equal to R delta theta, or ds is equal to R d theta. Yeah. So let's say we have this V is equal to ds over dt. Yeah. Basic equation for this average velocity or velocity adalah V is equal to ds over dt, and we know that ds is equal to R d theta is equal to ds is equal to R d theta over dt. And therefore, if we rearrange this, V is equal to R multiplied with multiple time d theta over dt. And we know that d theta over dt is equal to omega. It's equal to R omega. So we got the velocity equation for the velocity when we talk about this in the context of this normal tangent coordinate system. So velocity is always tangent to the curve path. And for this velocity equations, V is equal to R omega is equal to R theta dot. If we consider on the unit vector of tangents, we can write down the equation of V is equal to V tangent, and this one is V tangent. V is equal to R theta dot ataupun R theta dot ET. ET is the unit vector ataupun we can use ET ataupun UT which represent on the unit vector V is equal to R theta dot UT. Sama je benda ni sebenarnya. Word of ET ataupun UT itu sama. It depend on the what's so called reference books that we use. Different author, different notation of unit vector, but both has the same meaning actually. Ataupun V is equal to R omega UT for this what's so called velocity. The next is velocity in normal tangent coordinate systems, in XY coordinate systems. Let's say we consider that a particle P which move according to circular path of motion. So in this instance shows it has the velocity of V. Velocity of V, we know that V is equal to R omega. So we consider on this XY coordinate systems, we need to break it down into the component of X and also Y respectively. So kita akan dapat this V. Ini adalah Vx. Ini adalah Vy. Let's say it has an angle of theta, for example. So V is equal to Vx, Vy in the scalar form. Scalar analysis. V is equal to Vx, Vy, and Vx is equal to R omega cos theta. Vx Vx ni adalah Vy. Macam mana boleh dapat R omega cos theta? If you still remember on what we have discussed before in the previous lecture note, lecture 3, if I'm not mistaken, and you learn about the rectangular XY coordinate system. We need to apply the trigonometric identities or functions. So we have this Vx is equal to, you know, this V is equal to R omega rho. So Vx is equal to V cos theta. Vy is equal to V sin theta. And V itself is equal to R omega. That's why we got this R omega cos, R omega sin. So this one is equal to V adalah R omega. Therefore, R omega cos theta. Similarly to this one, Vy is equal to R omega sin theta. And again, if you want to identify or determine the magnitude of velocity, we need to apply the Pythagoras theorem of, V. So we need to, let's say, the magnitude of velocity V is equal to square root of Vx squared plus Vy squared. And that one is equal to R omega cos theta to the 2 plus R omega sin theta to the 2. So we need to apply the theorem Pythagoras. Theorem Pythagoras. That's what is applied in the rectangular XY coordinate system. So for this normal tangent, also we gonna use the same approach in obtaining the magnitude of velocity, and also we can find out also the directions of velocity. We do not know what is the directions. Special note in normal tangent coordinate systems. So we have this circle. In order to find out the perimeter S is equal to R multiplied with 2 pi. So 2 pi is equal to 360 degree. Pi is equal to 180 degree. So equal to 3.14 radian. 360 degree equal to 6.28 radian. So in solving the problems, we need to change from degree to radian. Degree to radian. Then you can multiply or add this. Distance travel, let's say we have these sections. The distance travel of ds is equal to r d theta. So s is equal to r beta. So this one is s. Daripada sini sampai sini adalah s. So s is equal to r kali dengan this, the angle of this equal to beta. R kalikan dengan beta. We got this distance travel of s. Angular velocity is omega radian per second. In engineering, normally they'll give you in form of rotation per minute. Let's say the disk is rotate at a speed of 200 RPM, for example. So this 2 RPM is stand for rotations, R is rotations, P adalah per, M adalah minute. Kan? So if you want to, let's say, to change into radian per second, so we need to use this formula. 1 RPM is equal to 1 RPM. Dia boleh tulis dalam huruf besar ataupun huruf kecil for this rotation per minute. Can, no problem. 1 RPM is equal to 2 by divide by 60 in radian per second. Okay. Contohnya, nanti saya tambah slide. For example, is how to convert RPM to radian radian per second RPM radian per second, sorry. Gitu lah. Let's say 200 RPM. Change into radian per second. So 200 RPM is equal to 200 multiplied with 2 pi over 60. So berapa tu? Cuba kamu kira. So class, what is the answer for this? 200 multiplied with 2 pi over 60. Apa jawapan dia? Okay. Cuba kira ni. Guna calculator. What is the answer for this? 200 RPM is equivalent to how many radian per second? So, siapa boleh jawab? Any one of you? Please answer this. 200 multiplied with 2 pi over divide by 60. Berapa?
20 over 3 rad per second.
23.
20 over 3 pi rad per second.
Oh, okay, 20.93 radian per second. Kamu kira. So, pi ni kamu kena tukar pada 3.14. So, maknanya 200 kali dengan 2 kali dengan 3.14 bagi dengan 60. So, akan dapat dalam bentuk sebutan yang macam ni. Okay, the next is the normal tangent components. So, the normal tangent component for the accelerations. For the accelerations, when we deal with this normal tangent method of solutions, we can use the equation of A is equal to AT UT plus AN UN. A is equal to AT UT plus AN UN. Okay. So AT adalah tangent component of acceleration. While AN adalah normal component of accelerations. And it is obtained by taking time derivative of velocity equation. If we take time derivative of velocity equation, at the end we can obtain the normal acceleration. We have the velocity equation v is equal to r theta dot u t. So this is the velocity equations for this normal tangent coordinate systems. If we take time derivative of these velocity equations, at the end we can obtain this equation of acceleration. We can obtain the equation of accelerations. Where at is equal to v dot. At is equal to r alpha. Tangent acceleration is equal to radius multiplied with angular accelerations. Ada derivation process ada on the next slide. But don't bother so much about this derivation process. The important thing is you know that this AT tangent accelerations is equal to R alpha. Just use this equation directly. Jangan nak pening-pening untuk derive. And for the normal accelerations, we can use the equation of AN is equal to V square divided by rho. Ataupun another one equation is AN is equal to R theta dot square. Sama juga dengan this R omega square for this normal acceleration. So untuk normal accelerations, we can use either these equations, AN is equal to R omega square, or we can use the equation of AN is equal to V square divided by rho. Rho is the radius of curvature. And again, for these accelerations, in order to obtain the magnitude of accelerations, we need to apply this theorem, Pythagoras theorem as well. So here is the derivation process on how to obtain the what's so-called acceleration equation. So dia pakai of course taking time derivative of these velocity equations, applying the Chain's rule of calculus. At the end we can get this equation. At the end this equation itulah yang kamu kena ingat lah. A is equal to R theta dot theta double dot ET is equal to R theta dot square EN, ataupun kita boleh tulis sebagai A is equal to R theta double dot U padam lah. We can also write it down as A is we can write down as A is equal to R theta double dot U T plus R theta dot square UN. Unit UN ataupun EN represent on unit vector. Or we can write it down as A is equal to R theta dot double dot is equal to alpha. Alpha is the angular accelerations. Theta dot is equal to equivalent with this what's so called omega with this angular velocity. Okay. Or we can write down as A is equal to R alpha ut plus R omega dot is equal to an is equal to V square divided by rho ataupun R UN. UN sendiri vector for this normal UN. And also what is explained before that we need to apply the Pythagoras theorem in order to find out the magnitude of acceleration as well. That's what it is. Pythagorean. Apply Pythagorean theorem. So that is what's so called acceleration equation, which need to be remember or memorize. This equation is important for you to remember. Okay, the next is concerned about normal tangent coordinate system for the accelerations. So if you look at these illustrations, so we have a particle which moves according to circular path of motion. So at this instance shows, this particle P has a normal accelerations of an, normal acceleration of an, which is directed toward this. This one is the center of curvature. On the center of this circle. So an, since we are applying this, let's say we want to apply this rectangular xy coordinates, x, y coordinates system. So the normal tangent coordinate system in xy coordinate system. So if we want to apply this xy coordinate system, each of these components, so we have this normal component of accelerations, break it down into the component of a and x, dan juga a and y. Dari dua dia ni, a and x dan juga a and y. So a and x dan juga a and y. For this an itself is equal to r omega square. So maknanya for this one, an is equal to a and x, a and y. Itu dalam komponen x dan juga y of this. And kalau this one, tangents, a tangent is equal to a tx and also a ty. Dia ada dua komponen. We break it down into the component of x dan juga y. X, y. So maknanya equation ni akan jadi lebih banyak. Expanding these equations from 1 to 2, from 2 it's become 4. Because we have the two component of an and also at, where each component has two component of x and also y, so dia akan jadi 4 komponen semua sekali lah. Kalau kita try to elaborate this dalam components X dan juga Y for this normal tangent coordinate systems. Of course, it becomes panjang lagi lah dia punya persamaan dia. Okay, the next normal component of acceleration represent the time rate of change in the directions of velocity. Since AN always act toward the center of curvature, this component is sometimes referred to as centripetal accelerations. So normal accelerations juga dikenali sebagai centripetal accelerations. Accelerations. So kalau dalam soalan dinyatakan dalam bentuk find the centripetal acceleration is actually represent on is equal to normal acceleration is equal to centripetal acceleration. So itu adalah AN. Kalau AT, tangent component of accelerations, represents the time rate of change in the magnitude of velocity. So magnitude of velocity for this AT, ini adalah A tangent. It represents time rate of change in the magnitude of velocity. Kalau dia punya velocity dia constant, if the velocity is constant, then AT is equal to 0. Okay. If velocity is so AT is equal to 0. If the velocity is constant, then AT is equal to 0 because velocity itu adalah constant. So acceleration dia akan jadi kosong. Okay. This one is for this tangent component of acceleration, but normal component of acceleration dia ada nilai dia lah. And AN is equal to V square divided by rho kan. Normally the velocity is given. So let's say they tells you that in the statement of a vehicle is moved according at a speed of 20 meter per second. Let's say like that. So it's represent on the velocity, which move according to circular path of motion or curvilinear path of motion as shown in figure blah 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 sebagai contoh. So V itu dinyatakan. So if V is given, then we know that the radius of which is given, then we can find out what is normal acceleration. Okay, the next is for magnitude of the normal component. AN is equal to V square divided by rho. AN is equal to V square divided by rho, sama lah dengan ni. Tadi. If the path is expressed as Y is equal to Fx, the radius of curvature rho at any point on the path is determined from, so dibagi dalam bentuk Y is equal to Fx as a function of X. So maknanya X adalah Y. Let's say we have this kind of situations which move according to this particular move according to curvilinear path of motions. So ni adalah V. So ni adalah Y is equal to, let's say 2x. Contoh lah 2x. So Y as a function of X, as a function of X. So V ni adalah V. Let's say that's point A sebagai contoh. So we can use these equations in order to calculate the radius of rho, radius of curvature. So rho in this case can be obtained by using the equation of rho is equal to 1 plus brackets dy over dx to the 2 close bracket for this overall equations on top of this line to the 3 over 2 1 plus dy over dx to the 2 close bracket 3 over 2 power of 3 over 2 divide by d to the 2y over dx to the 2. So jangan confused with this one and also this one. So the first one, dy over dx, is the first process of derivations for the equations of y is equal to fx. Y as a function of x, bila kita apply this what's so called derivative for the equation of y as a function of x, kita guna pakai dy over dx lah, ataupun d over dx y. We take time derivative, not the time derivative, because this one y dengan juga x. So kalau dy over dt tu lain. So maknanya the first step of derivations, and this one is the second step of derivations, d to the 2y over dx to the 2. Kita akan lihat pada contoh nanti sebentar. Here we have this example 1. We continue with this example 1. So when the skier reach the point A along the parabolic path, he has a speed of 6 meters per second, which is increasing at 2 meters per second squared. So we have this skier which move according to this sloping path of motions. It has the so-called the parabolic path of y is equal to 1 over 20x to the 2. So mana dia bila dibagi soalan dalam bentuk yang macam ni, iaitu dalam bentuk y as a function of fx, y dan juga x. So terus ingat kepada equation of rho is equal to 1 plus dy over dx to the 2 So terus ingat dengan persamaan yang baru dinyatakan sebentar tadi, which is y is equal to 1 plus dy, dy pula, rho. So rho, the radius of curvature, rho is equal to 1 plus dy over dx close bracket to the 2 power of 3 over 2 kuasakan 3 per 2 divide by d to the 2y over dx to the 2. The first step of derivative, second step of derivative for this one. So the question is determine the direction of his velocity, of this skier velocity, and the directions and magnitude of accelerations at this instant. So neglect the size of the skier in the calculations. So of course, in solving these problems, you need to come up with the illustrations ataupun free body diagram. Okay, we continue with this solution. So solutions. Example 1. First step is NVD lah. NVD. So we have this curve related parts. So in this instance shows the scale reach at this point A. This point A. So this curve part, the equation for this curve part is y over y is equal to 1 over 20 x to the 2, right? 1 over 20x to the 2. And at A, it has the velocity of 6 meter per second. So kalau kita lihat kat sini, dia this axis of x dan juga y. So y is equal to, at A, y is equal to 5 meter. At A, y is equal to 5 meter and x is equal to 10 meter, right? Okay. So, and again at A, it has the velocity of v is equal to 6 meter per second, VA. Kenyataan dia, he has speed of 6 meter per second, which is increasing at 2 meter per second square. So the statement of which is increasing at 2 meter per second square is actually represent on tangential component of acceleration. So dekat sini ni dia ada, since it's move according to this curve part of motions, akan ada tangent dan juga normal direction. So ni adalah N dan juga T lah. N dan juga T. So at this instance shows, at A it has the velocity of VA which is equal to 6 meter per second square, which is increasing 2 meter per second square. Tadi velocity alam V is equal to VA is 6 meter per second. Sorry. So dia ada this A. So this AA kita kena nyatakan which is actually represent on AAT. The tangent component of accelerations, where AA tangent is equal to 2 meter per second square. 2 meter per second. So they ask you to find what is the directions of his velocity. Direction maknanya dia sudut dia. So dekat A tu, sudut dia tu. Or the direction of velocity. It means that at A, what is theta? So kalau kita extend this, disambunglah this theta is equivalent with this theta. Right? Since they give you in form of data given, y is equal to 1 over 20, 1 over 20x. So 1 over 20 x to the 2. So if we take first the derivative dy over dx. Therefore, dy over dx equal to d over dx multiplied with y. So d over dx multiplied with y, so it's become d over dxy 1 over 20 x to the 2. So we dy over dx, bila kita derive, yes. Take time derivative or differentiate this one. If we differentiate d over dx multiplied with y, so we can get this 2 times 1 over 20, we can get this 1 over 10 x. dy over dx equal to 1 over 10 x multiplied with x. So add, ini adalah dy over dx. Add a x is equal to 10. 10 meter. Therefore, sorry. So therefore, dy over dx is equal to 1 over 10 multiplied with 10 is equal to 1. So dy over dx is equal to 1. Since dy over dx is equal to 1, that one's actually represents only, you know that we have this curve like something like this. Ini adalah A. Ini adalah A. This is the horizontal line. They ask you to find out what is theta. So in this case, this one also theta. So ini adalah dx, ini adalah dy. Okay. So if you look at these illustrations, tangent theta is equal to dy over dx. Theta is equal to tangent minus 1 dy over dx. And we know that dy over dx, at the previous one, is equal to 1. Therefore, theta is equal to tangent minus 1 dy over dx, ini adalah 1. So tangent 1 is equal to 45 degree. Okay. 45 degree for this directions. Is there any questions? All right. So we continue with this how to, they ask you to find out what is the directions and magnitude of acceleration. Magnitude or directions of accelerations. So the next step is we need to find out what is the magnitude and directions of acceleration. find magnitude and directions of acceleration. Of A, of Q and A. So you know that acceleration equation adalah A is equal to AT UT plus AN UN. And AT is equal to 2 meter per second square. So it is given in the questions, in this question. While the velocity is 6 meter per second, which is increasing at 2 meter per second square. So increasing at 2 meter per second square is actually represent on tangential component of accelerations. The one that we need to find out is AN. AN is equal to V square divided by rho. And rho is unknown. V is equal to 6 meter per second. So rho is unknown. So since rho is unknown, then apply the equations as follows. So rho is equal to 1 plus dy over dx to the 2 close bracket 3 over 2 divided by d to the 2y over dx to the 2. So dy over dx ikut step yang sebelum tu sama dengan 1 per 10x. D to the 2y over dx to the 2 is equal to d dy over dx. Dy over dx kali dengan d to the 2y over dx to the 2 adalah dy over dx kalikan this dy over dx. Sorry, this one is should be not dy, d over dx over d to the 2y over dx is equal to d over dx kalikan dengan dy over dx. And we know that dy over dx adalah 1 per 10x. So what will happen is that one is equal to d over dx 1 per 10x. So dia akan jadi apa ni? 1 per 10 saja 1 per 10. So once you got this d to the 2y over dx is equal to 1 over 10. What you need to do is you substitute whatever the data which is obtained from the previous step into this equation. Therefore, rho is equal to 1 plus dy over dx adalah 1 per 10x close bracket and then close lagi satu yang besar dua per tiga dua per tiga 3 per 2 sorry 3 per 2. Ini pun lebih kurang ni equation ni. 1/10, this one should be kuasa 3/2 kuasa 3/2 ni kuasa 2 divide by d to the 2 y over dx to the 2. So kita dah dapat dia punya jawapan dia. Rho sama dengan 1 campur 1/10 X. Bila X sama dengan 10 meter, maka nilai dia adalah 1/10 saja. 1/10 kali 10 jadi 1 lah. 1 kuasa 2, itu dia. Boleh lihat. Kuasa 3/2 bagi dengan d to the 2 y over dx to the 2 1/10. So when you solve this one, what we can get is this one is equal to 28.28 meter. 28.28 meter. Right? So once you got this rule, then we can go to the next step, how to calculate or determine the velocity, normal component of velocity. So Vn is equal to V rho divided by V square divided by rho, sorry. Vn is equal to V square divided by rho is equal to V adalah 6 kuasa 2 bahagikan dengan rho dia adalah 28.228. 28.28. So when you solve this one, you can get the answer for this normal value. This one is not betul ini. Okay, this one it should be A, can you B? This one should be AN. BN. AN. So AN is equal to V square divided by rho is equal to 6 to the 2 divided by 28.28. Then if you try to calculate this one, you got this 1.273. In meter per second square for this AN. So once you got this AN, then we can apply this Pythagoras theorem. A is equal to square root of AT to the 2 plus AN to the 2 sama dengan 2 kuasa 2 campur 1.27. Okay. Kuasa 2. Okay, if you solve this one, you can get the answer for this magnitude of acceleration, which is 2.37 meter per second square. Okay, class, and then you can find out what is the directions of accelerations. So we can assume that macam ni kan. So dia adalah AT, dia akan ada AN. So AT sama dengan 2. AN sama dengan 1.273. And therefore, A ni adalah A. Okay. Dia adalah, let's say, this how to mention this one. How? P or 5. This symbol which represent all the direction as well. So tangents P is equal to AT divided by AN. So this P is equal to tangent minus 1. AT dia adalah 2. 2 bagi 1.273. So you got the answer for this. P is equal to 57.5 degree. So itu boleh memadai sampai this step. So that is the directions of accelerations. Yang ni adalah magnitude. Ini adalah magnitude. Magnitude of acceleration. Method dia buat dekat sini sebenarnya. So I just elaborate lah. So hope that you can understand. Okay, let's continue with this example 1. Try to do this example problem 1. So if you look at these illustrations, problem 1. At a given instant, the jet plane has a speed of 120 meters per second and accelerations of 21 meters per second squared, acting in the direction shown. Okay, so we have this jet plane. The velocity v is equal to 120 meters per second and accelerations of 21 meters per second squared. Acting in the direction shown. So this A represent on the magnitude of acceleration, actually this one. A itself represent on the magnitude of accelerations, which is equal to 21 meter per second. This one. Meter per second square. So the question is determine the rate of increase in the plane speed if theta is equal to 60 degree. Yeah. Determine the rate of increase in the plane speed. Rate of increase mana dia? In the plane speed mana dia? What is the component of accelerations? What is the tangent component of accelerations and what is the normal component of acceleration? So you need to find out what is good of that component. So that is the first question. The second one is find the radius of curvature rho of the path. Okay. Let me show you on the method of solution for this. Okay. Okay, solutions. problem 1. So the jet fighter or jet plane, so like this, simply like this. The velocity is v, which is equal to 120 meter per second. This one is rho. So we do not know what is the radius of curvature, and it is given that the magnitude of acceleration is given, which is equal to 21 meter per second square. So V is equal to A is equal to 21 meter per second square. So the answer to find out what the rate of increase at this instant shows. So dia akan ada komponen this tangent, A tangent, dan juga akan ada lagi satu komponen which is A normal, AN dan juga AT. So this is the one that we need to find out, what is AN and also AT. And at this instant shows, it is given that theta is equal to 60 degree. So by applying the trigonometric functions or identities, so yang ni kita boleh buat dalam bentuk yang macam ni lah. So this one is A tangent. This one is, this component is represent on this A normal. This one is AN. And magnitude of acceleration is 21 meter per second square, and it's given that theta is equal to 60 degree. Therefore, through these illustrations, sine 60 degree is equal to AN over 21. Therefore, AN, which is normal acceleration, is 21 multiplied with sine 60 degree. Okay, and then AN is equal to cuba kira berapa jawapan dia. Dua puluh satu kali sin 60, which is equal to 18.19. Meter per second. So we got AN. So the next step is using the cos. Cos 60 degree is equal to, let's go back to the previous slide. Cos 60 degree, AT over, or AT divided by 21 is equal to AT, A subscript T, tangent accelerations, divided by 21 meter per second square. Therefore, AT is equal to 21 multiplied with cos 60 degree. So you got the answer, you got the answer of 10.5 meter per second square. So here is the component of accelerations, a tangent component of accelerations, and also this one is a normal component of accelerations. So the next step is they ask you to find out what is the radius of curvature rho. We know that AN is equal to V square divided by rho. If we rewrite these equations, AN multiplied with rho is equal to, sorry, AN multiplied with rho is equal to V square. Therefore, rho is equal to V square divided by AN. And we know that V square, the velocity is given that it has the plane speed, jet plane speed is equal to 120. So in this case, V is equal to 120 power of 2 or to the 2 divided by AN. AN is equal to 18.19. 18.19. Okay. So when you solve this one, we call the answer for this row. This row is equal to 792 meter approximately. So you have already got the answer for this radius of curvature. Okay. Okay, class. You got any questions?
Yes, it's 120.
Ya. Ada soalan tak untuk problem 1 ni? Tak ada Okay, let's have a look on the problem 2. Problem 2. A lorry is traveling along a circular curve that has a radius of 50 meter. Okay, tambah here. So the question is, a lorry is traveling along a circular curve. So you can imagine a circular curve that has a radius of 50 meter. If its speed is 16 meter per second and is increasing uniformly at 8 meter per second square, determine the magnitude of its acceleration at this instant. So you can illustrate this one. Solution. Let's say it's more according to this circular curve, right? This lorry, this lorry P. It has the radius of curvature, which is rho is equal to 50 meter on the radius, rho ataupun R lah. R is equal to rho is equal to 50 meter. If its speed is 16 meter per second, so at this instant shows it has the speed of V, which is equal to 16 meter per second, and is increasing uniformly at 8 meter per second square. So maknanya dalam masa yang sama, it has the tangent component of accelerations, which is equal to 8 meter per second square. Determine the magnitude of its accelerations. Find A. So A is equal to AT UT plus AN UN. Kan? And A is equal to, kalau nak dapat dia magnitude, square root of AT to the 2 plus AN to the 2. So you need to find out what is AT dan juga AN before you obtaining the magnitude of accelerations. Okay? So in this case, AT is given, AT is given, AT is equal to 8 meter per second square. So what you need to do is you need to find out what is AN. AT is equal to 8 meter per second square. AN is equal to, we do not know. So you need to find it first. You know that AN is equal to V square divided by rho. And AN is equal to V square is equal to, this case V square is equal to V adalah 16 meter per second. So 16 to the 2 divided by rho dia adalah ataupun R 50 meter. 50. And therefore you got this AN. Which in this case AN dia adalah, if you calculate this one, 5.12 meter per second square. And therefore, the magnitude of acceleration A. So A is equal to square root of AT to the 2 plus AN to the 2. Just substitute into this equation all of the result that you obtain from the previous method of solutions, which in this case AT adalah 8 kuasa 2 plus 5.12 to the 2. And therefore, if you solve this one by using this Pythagorean theorems or Pythagorean theorem of Pythagoras, you will get the answer for this, which is equal to 9.50 meter per second square. Okay. So that is the magnitude of accelerations. Is there any question in class before we dismiss it? We have another one problem. Try to do it. I will share the answer as well for this one later on. If you can, you can do it by yourself. Try to do it first. You can get the answer for this problem 3. Kalau ada problem boleh tanya lah, tapi nanti saya akan share juga lah dia punya jawapan dia. Okay. Don't forget that tomorrow you have test 1. So probably tomorrow afternoon I'll share. We will conduct the class through the offline. Offline is mean that I'll share the recorded version so that you can try to watch the video regarding the next topic, which is concerned about radial transverse coordinate system and also relative motion. Relative motion kita akan buat secara online lah nanti. And for your information that the topic which involved in test 1 I've already shared with you last week. So you need to focus on rectilinear motions. Rectilinear motions. What is the velocity? What is the displacement? What is the average velocity? How to apply that kind of equations? what is the average speed, what is the difference between average velocity and also average speed, how to apply the what so-called accelerations, how to find out the accelerations by using those kind of equations, whether you need to apply the variable kinematic equation of motions or constant acceleration equation. So constant acceleration equation dan juga variable kinematic equation of motion. So you need to differentiate between all of that. Kalau dalam soalan tu dia nyatakan secara spesifik the constant acceleration is equal to blah blah blah. So you need to apply that kind of constant acceleration equation to calculate the velocity sebagai contoh ataupun the distance s kan. And then you need to try to revise on especially for the lecture 2 tu untuk contoh-contoh yang diberikan method of solution for the erratic motion sebagai contoh kan. Erratic motion which is concerned about the problem which is shown graphically. Dia ada gambar rajah kereta ke motor ke whatever it is, dan juga adalah dia punya graphical expressions in term of its motions pada time range berapa sehingga berapa, macam mana dia punya orang kata tu motions, adakah ianya dalam bentuk orang kata tu persamaan ataupun kalau constant mana dia nilai sahaja yang diberikan. Dalam contoh-contoh yang diberikan tu, try to familiarize with that kind of method of solutions. Itu adalah antara perkara yang akan keluar dalam apa tu this test one. Similarly to this projectile motion, try to understand exactly on how to solve the problem which is concerned about the projectile motions. Dan last question adalah berkait rapat dengan this normal tangent coordinate system lah. Okay, kelas?
Okay, sir. Okay.